Good morning. In today's class, we will learn about the implementation of breadth-first search technique. We already know what is breadth-first search. Now, in today's class, we are learning about the implementation of breadth-first search. First, we will begin with the algorithm. Here, BFS with vertices and start, and here input is the list of vertices and the start vertex, and the output is traversing all of the nodes in BFS if the graph is connected. So we'll begin with an empty queue, and at first mark all the node status as unvisited while queue is not empty. Add starting vertex into the queue, and while queue is not empty, we are deleting the recently inserted node from the queue and set to U. Display the vertex U, and for all the vertices one adjacent to U. All the vertices adjacent to U, you are do vertices of I is unvisited, then mark vertices I as temporarily visited, add V into the queue, then mark as completely visited. This is the algorithm of BFS, and we will see how this is done. To implement the BFS, we are making use of queue as the data structures, and all the vertices are visited from level 0, level 1 and so on, one level at a time. So to begin with, insert source vertex into the queue. Select any vertex as a source vertex and insert that vertex into the queue. Then repeat the following steps into the queue until the queue is empty. Delete a vertex from the queue and the vertex is visited or processed. The most recently inserted element or node is into the queue is deleted from the queue, and all the adjacent vertices to the node are inserted into the queue. You can see then all the nodes which are adjacent to the deleted vertex but not visited earlier are inserted into the queue from left to right. We will take up an example and see the implementation of BFS. So in this graph, you can choose any of the vertices, the starting vertex, and initially the queue content is empty. I am choosing vertex A as the starting vertex, and I am inserting vertex A into the queue. Then I am deleting that vertex from the queue and marking it as current vertex, and all the vertices adjacent to A are inserted into the queue. Here the vertices adjacent to A are B and G, which are inserted into the queue. Then front element of the queue is deleted, B is deleted, and all the vertices which are adjacent to B are inserted into the queue. The vertices adjacent to B are C and F, you can see, which are inserted into the queue. Then front of the queue is G, which is deleted from the queue and marked as current vertex, and vertices adjacent to G are H and F. F is already in the queue, so H is inserted into the queue. Then the most front element of the queue is deleted, that is C is deleted from the queue, and the vertices adjacent to C are D and E are inserted into the queue. Then front of the queue, H is deleted from the queue and marked as the current vertex, and F, vertices adjacent to F are B and G. Which are already there in the queue. Then the most front of the element, that is H, is deleted from the queue, and the vertices adjacent to H are I and J, which are inserted into the queue. Then similarly, D is deleted from the queue, and the vertices adjacent to D are inserted into the queue. And similarly, I is deleted from the queue, and the vertices, there are no adjacent vertices to I, so you are not inserting again. Then J is deleted from the queue, and now the queue is empty. So this is the current BFS traversal for this tree is A, B, G, C, F, H, D, E, I and J. The order in which the nodes are visited by a BFS that starts from the vertex A is A, B, G, C, F, H, D, E, I and J. The resultant tree, that is the breadth first search tree, is like this: A, B, G, then C is visited, F is visited, then H is visited, then D is visited, E is visited, I and J are visited. You can see that the lines with dark edges are tree edges, that is they are forming the binary tree. Then you are marking the cross edges here. Cross edges are the edges which are already visited, hence you are marking it in the dots. So you can see here what are tree edges. Edges in the breadth first search tree. An edge V to W is a tree edge if W was first visited when exploring the edge V to W, and all the other edges are cross edges.